Welcome to Lady May's explainer video. Today we'll talk about the trigonometric identities using the hexagon trick. Are you so overwhelmed by how much formulas that you needed to memorize in trigonometry? Well, you are not alone. And you don't have to worry, as today, I am going to show you how this super hexagon trick works, and I hope that you would be as amazed as I am by how much helpful this hexagon trick is. Let me show you how this works. The first thing that you need is a hexagon. Now that we have our hexagon, let's point up the vertices. These vertices are important as this is where our trigonometric functions are gonna be. Next, draw the diagonals. Our hexagon is now ready for setup. Let's set up these functions one by one using the reciprocal identities. This is the most crucial part as you need to correctly input the positions of the functions. Sine function should be on the top left vertex. The reciprocal of sine is cosecant or CSC. Cosecant must be put in the point end of the diagonal connecting to sine. Next to sine is the cosine function, and the reciprocal of cosine is secant. Then, we have the tangent function, of which has a reciprocal of cotangent. Our hexagon is now fully set up. There are several identities that we can derive from this hexagon, and one of them is the quotient identities. In the quotient identities, there are two patterns of direction that we can follow, the clockwise direction and the counterclockwise direction. Let me show you how the clockwise direction works by giving an example. Example: the tangent of an angle is equal to sine divided by cosine. The same pattern is being followed by the next example. The sine of a certain angle is equal to cosine divided by cotangent. The same pattern of formula shall be followed all throughout the hexagon in a clockwise direction. Now let me show you how the counterclockwise direction works. It is just of the same pattern of formula as our previous examples, the only difference is the direction. Example: the cotangent of an angle is just equal to cosine divided by sine. The same pattern with cosecant is equal to cotangent divided by cosine. Another identity that we can derive from this super hexagon is the cofunction identities. This will show you the complementary trigonometric function of the other angle. Say for example, sine and cosine are cofunctions and complements. Tangent and cotangent are cofunctions and complements. Secant and cosecant are cofunctions and complements. The next identity that we'll tackle is the product identity. Unlike the reciprocal, quotient and cofunction identities, product identities needs one at the center of our hexagon for its pattern of formula. In this case, you have to choose a vertex. That vertex is the product of the surrounding trig functions. Example: the product of the tangent of an angle and the cosine of an angle is equal to the sine of an angle. The product of the tangent of an angle and the cotangent of an angle is equal to 1. The same pattern shall be used to all other functions. The last identity that we can derive from this hexagon is the Pythagorean identities. This is a little bit more complex than the others. The highlighted inverted triangles is where our formula should be derived. The first thing that we should do is to add a plus sign in every triangle bases. Then, add an equal sign in the center of every triangle. In here, we are going to read the trigonometric functions from top to bottom, but with a twist. The functions here are squared. So instead of reading it as a sine of a function, we rather say it the square of sine function. For example, the square of sine function plus the square of cosine function is equal to 1. And the square of a tangent function plus 1 is just equal to the square of a secant function. The same pattern with 1 plus the square of cotangent function is equal to the square of cosecant function. Thank you for watching, and I hope you learned something in this video. Don't forget to like and subscribe for more tricks.